This is R.D. Sharma solution, class 12, chapter 15, mean values theorem. Exercise is 15.2. Now this question, we have already done a question like this, just the previous few questions we have encountered. It was under root 25 minus x square, if you remember. So we'll attempt this one also, because if this kind of question comes, then you'll be able to do it. So whenever an under root is encountered, please remember whatever is inside under root should not be negative. It cannot be negative. So this thing is only verified, or it is only possible when this under thing which is inside the root, which is x square minus 4, is not equal to any negative number that is greater than or equal to 0. That is x square. When you compare it with 4, you know the inequality, you know that it has to go out of 2 and negative 2. That is, I'll just show you here. X square is between 2 and infinity and negative 2 and infinity, that we have already seen in our previous discussions. So this is how it will go. See, this is negative 2, this is 2, and this x square minus 4 will only be defined when we are below negative 2 or above 2. And since we are given 2 and 4, this is the domain, so this is verified, and this x square minus 4 will never be negative in this interval. So this function is defined first of all, and then we can go about the continuity and differentiability, and then we can go to the MVT, that is Lagrange's mean value theorem. Again, x square minus 4 cannot be negative. The way I told you, 25 minus x square cannot be negative. That is the first thing you have to check when you have a under root. Fx is between 2 and 4. So we just know that it is continuous. Then this next one is the in LMVT, Lagrange's mean value theorem. We'll do the differentiation. And this differentiability and continuity has to be established first. Then we go to this differentiation, nx to the power n minus 1. You can do half x square minus 4 to the power half minus 1. That is negative half. This x square minus 4. This will be 2x. The differentiation of x square minus 4 will also be done. 2 gets cancelled. You have x and divided by x square minus 4 to the power half in the denominator. Now this is between 2 and 4. And you will get at least a single value, means there can be multiple, but there will be some value between 2 and 4 that will be following the MVT theorem specifications, and those are what? FB minus FA by B minus A. That is, see, between 2 and 4, x by under root x square minus 4 is defined. So I told you about continuity, I gave you all the discussion and the explanation. How about differentiability? Differentiability can be ascertained from this one. Under root x square minus 4 will never be negative between 2 and 4, and it is also defined in 2 and 4, this particular differentiality. Then we can equate it with this FB. B will take as 4, A will be 2. So we have 4 minus 2 is 2, of course, in the denominator. FB is under root. You have to put in the original equation, please remember, f4 is under root 4 square minus 4. This is 16 minus 4, 12. And 12 is 4, 3 is 12. So 2 comes out of the root and 3 remains inside. It will be twice root 3. This is f4. I have placed 4 in the original equation, that is fx equals to under root x square minus 4. That has to be understood well. Then we have f2, just put x as 2, 2 to the 4, 4 minus 4 is 0, under root 0 is 0. You get a value 2 root 3 and under root 0, that is 0. So this is 2 root 3 minus 0 divided by 4 minus 2. You get 2 root 3 divided by 2. 2 gets cancelled, you get only 3, under root 3. Now we have two things, fb minus fa by b minus a. And we have differentiation also, which we have already done, x by under root x square minus 4. Let us equate it with this one. And then you have to solve it. We have x by under root x square minus 4. You can equate it with root 3. And then just multiply cross. X is equal to root 3 into root x square minus 4. Then you can x square will be equal to 3. X square minus 4. X square will be equal to this, multiply it. and then you will get this 2x square minus 12, x square will be equal to 6, and x will be equal to plus minus under root 6. Now since this is between 2 and 4, there cannot be any negative, so just discard that negative one. Negative root 6 will not be defined, only plus root 6 will be there. Plus root 6 will be the eventual thing which you are going to say, oh, this thing is okay. You will not go to the negative part, you just have to go to 2 and 4. That is the domain in which we are talking about, or we are discussing all these function things, MVT or Rolle's or etc. So plus under root 6 is the Lagrange's theorem value when all the conditions are being met. So how are we going to write? This is what I have explained, and this is what I want you to write. All the English sentences, all the conditions which you know, you have to write it here. This is x square plus x minus 1. I am just going past it because we have already done a question like this. This question is also with some sine and cos we have already done, but we will complete it because this has some things which are involved that needs to be explained. Sin x, sin 2x or x, all these three are continuous also and differentiable also. See, in MVT, don't worry about any of these terms in this equation. All the terms are individually what? They are continuous and differentiable. LMVT conditions are being met. The next one is, you have to equate it with fb minus fa by b minus a is equal to f dash x. First, let us find out f dash x. We are going to differentiate it. Sin x is cos x, sin 2x is cos 2x, 2 will come in front, and this minus 1. This is your f dash x, this is your differentiation. Cos x minus twice of cos 2x minus 1. Then we have fb minus fa by b minus a, that you already know what we do. So we have b as pi and a as 0, f pi and f 0. We have cos pi minus 2 cos 2 pi. Oh no, not in this one. What am I doing? We have to put it in the original equation, right? Sin x minus sin 2x minus x. Okay. Sin pi minus sin 2 pi minus pi. Then we have sin 0 minus sin twice of 0 minus 0. See, sin pi 0, sin 2 pi 0, only negative pi is going to remain. You know that sin n pi, n is an integer, everywhere it is going to be positive, always 0. Sin 0, 0, sin pi 0. See, sin 0, as I said, this is just for the people to recall that all these things with n pi will 0, but you will remain with negative pi. Here it's 0, 0, minus 0 minus 0 minus 0. It's going to give you 0. So this is 0, this is pi. fb minus fa by b minus a. This is minus pi. This is minus 0. And this is pi minus 0. We have this as negative 1. You will get negative 1 only. Now this differentiation we have already done. The value of fb minus fa by b minus a is also being computed. The thing is, the next step will be to equate it. Cos x minus twice of cos 2x minus 1 is equal to this minus 1 minus 1 get cancelled. You get cos x, and we cannot do anything with cos x and cos 2x. So we have to convert this cos 2x into 2 cos square x minus 1. So cos x minus 4 cos square x plus 2 equals 0. And this, let us multiply with negative 1 and rearrange 4 cos square x minus cos x minus 2 equals 0. Just assume it to be cos x as x, because we are going to solve first it as a quadratic equation. There will be no factor here. You have to go with the Sridharacharya formula. X will be minus b plus minus under root b square minus 4ac by 2a. And this is your a as 4, b as negative 1, c as negative 2. This is x will be equal to, you have all the values, you can just put it here. I'll just go with the final solution which I can provide you. 1 by 8, 1 plus minus under root 33. This plus minus outside or plus minus inside will be same. So this is not x, remember it was cos x. So x will be equal to cos inverse, as I said, plus minus can be taken inside, 1 by 8, and this is plus minus. So we have 1 plus minus under root 33. Now you see this 0 and pi we are talking about. As I said, and you can verify and check also, this both value will lie between 0 and pi if you check it. Now f pi minus f 0 by pi minus 0 you have equated and you got the x value. Now this whole process has to be written properly. This is the actual solution. So this is how you are going to write actually in your examination or in your classwork. So I normally first explain you, then try to show you the actual reference so that you can be well aware how you are going to write and present it to your examiner. This is a very clear-cut polynomial x cube minus 5x square minus 3x. So we can just go ahead with this and I can just show you the reference. Now discuss the applicability of Lagrange's mean value theorem for the function modulus x, absolute value of x. It is between negative 1 and 1. Now you see, in Lagrange's mean value theorem, also in Rolle's also, you have to first tell that or verify that it is continuous. Then the second thing is differentiability. Then the third step comes. Do you think this is differentiable? If you recall your continuity aptitude or discussion, you'll see mod x, it will be x when x is greater than or equal to 0. It will be negative x when x is less than 0. This you already know. So there will be a continuity. I'm not saying that there will not be continuity, but the catch is it will be not differentiable, because there is a sharp turn here, sharp shift. So this sharpness of that point is the problem. So differentiability is not with this modulus x. Continuity, you can say it is continuous, but differentiability is not there. So there is no point in discussing Lagrange's mean value theorem for this because of the fail in differentiability. This is, you have to write everything which I told you has to be written properly in this manner so that the examiner would understand that you know what is the problem. In the same way here also, 1 by x, negative 1 to 1. Now if you see there is a value x. Now this x value is between negative 1 and 1. So if this 1 by x is defined in this whole interval, then you can talk about continuity, differentiability, etc, etc, etc. But the problem is, when you have a 0 in the denominator, 1 by 0 is what? It's undefined. So the function is not even continuous. If it is not continuous, there is no point in going to differentiability, and there is no point in discussing Rolle or Lagrange's. So the idea of this question or the previous question, the whole idea is that you have to know whether the function in this particular interval or in this domain is continuous or if continuous, then differentiable. If these both are met, then we go ahead. Verify the hypothesis and conclusion of Lagrange's mean value theorem for the function. So x is between 1 and 4. So x belongs to 1 and 4 in this case. So we have 1 by 4 x minus 1, and if you put anything x, which is giving you a 0 value, then this function will also not define. So if x is between x is equal to 1 by 4, because the problem is 4x minus 1 cannot be 0. When we put 4x minus 1 equal to 0, you get x equal to 1 by 4. And if I can show you through the number line, you see this is 1 and 4 is the domain, but 0.25 is not lying in this domain. It's 0.25. It's 0.25. It's not in the domain. So we are safe here. We can easily say that the continuity and differentiability, we can go ahead, and continuity has no problem here. And this 4, let us differentiate it. 4x minus 1 to the power negative 1. So nx to the power n minus 1, let us start with that. 4x minus 1 to the power minus 2. Differentiation of 4x minus 1 will be 4. It will be negative 4 divided by 4x minus 1 to the power 2. This is your differentiation. Next one is fb minus fa by b minus a. What is a? 1. What is b? 4. fb minus fa by b minus a. This is 1 and 4. This is, now you have to put these value in the original equation. Please remember, you have to put it in 1 by 4x minus 1, not in the differentiation function. 1 by 4 into 4 minus 1 is fb. This is f4. f1 is 1 by 4 into 1 minus 1. It's 1 by 16 minus 1 is 15. 1 by 4 minus 1 is 1 by 3. fb minus fa, 1 by 15 minus 1 by 3 divided by b minus a. What is b? 4. What is a? 1. 4 minus 1 is 3. So this goes 3 minus 15 by 15 into 3. And 3 is in the denominator. You have minus 12 divided by 15 into 3 into 3. And this 3 4s are 12. This is minus 4 by 45. Negative 4 by 45 it is. This has to be equated to this one, f dash x. Negative 4 by 45. And this will form a proper equation. That is, let me write it properly. This is equal to negative 4 by 45. Negative 4 can be cancelled. 45 is equal to 4x minus 1 squared. You have 16x squared plus 1 minus 2 into 4x into 1. It will be 8x. And this 45 can be taken on one side. As let me just put the value and tell you. What do you get finally? This, when this is rearranged, this will be a quadratic equation. And if you are able to solve this quadratic equation normally, it will be real good. And I'm not going to solve it. I'm just going to tell you what is the value, because quadratic equation solving is, I think, a piece of cake for you. This is going to come x as this is going to come. And we already done this. This is going to be between x or c, 1 by 4, and then we have 1 plus 3 root 5. You have to reject the negative value. 1 minus 3 root 5 will not be between this domain. So by Lagrange's MVT, we have found the value. This is the solution which I just explained. You can just have a reference here and then we go ahead. So this question, if just imagine you are not doing this exercise, you are in the exam. How are you going to find out or anticipate that this is a question of either Rolle's or it can be solved by Lagrange's mean value theorem? It will not be possible, right? But if we do certain question like this, we will be able to do it. We have x minus 4 whole square that can be written as a square plus b square plus 2ab. That 2ab, this x square minus 8x plus 16. Okay. Now find a point in the parabola. So there is a curve which is a parabola. Now where the tangent is parallel to the chord joining 4, 0 and 5, 1. Now in MVT, if you remember, when I explained this MVT theorem, this a and b are nothing but the x point, and the x point are placed in this function and the y value is computed. That is how things goes. You have x as the independent value and y is the dependent value. We have 4 and 5 are the x value and we are interested in x value. If you have two parallel lines in MVT, what happens? In Role, it has to be parallel to x-axis. It is the requirement. But here, it is not that requirement. The point from where things start can come to an end which is not parallel to x-axis. But the x remains the same for both the lines, parallel lines. So x will be 4 for the first one, that is a and b, which is the domain of x. X value is always the domain and y values are always the range. So you have 4 and 5 as the domain. Alright, I hope you understood this. So if you start with this, in Roles, you have to come back to the same point. That is same point, I mean same y point. Same point on the y-axis. X will change. Here x is changing in the MVT, y is also changing. But the two lines will always remain the same. Here the tangent, two lines I am talking about the tangent on the curve. In Role, the tangent to the curve will always be parallel to x-axis. In MVT, the tangent which is parallel to the curve should not be parallel to x-axis. It is parallel to this chord which is 4051. You don't have to do anything with this 40 and 51 except 4 and 5 has to be taken as the domain range of 4 and 5. I hope you have a fair idea now. Now see, we will find out FB and FA, that is F5 and F4. This is 25 minus, this is F5. I'm putting in the original equation, remember. And when I put this, we will get some FB and FA value. And FB minus FA by B minus A, as I told you, B minus A will simply be 5 minus 4, which is 1. So the denominator will not count, it is just 1. But here we have, this is 16 plus 16 minus 32. No, F4 is going to be, so there is a slight change here because we have this f dash x also I am finding out. F dash x is 2x minus 8. So you have 16 and 25, which is your 41. 41 minus 40 is 1. And this is, see, 16, as I told you, 16 plus 16 minus 32. So as I said, there is a slight mistake or change here. It is going to be, it is 0. So you will get a 0. So you have FB minus FA by B minus A. You will get FB minus FA here, B minus A here. We have 1 minus 0 divided by 5 minus 4, that I already told you it is going to be 1. So you'll get 1. Now this has to be equated to the differentiation. So we have 2x minus 8, that is the differentiation, and we'll equate it with 1. So 2x will be equal to 8 plus 1, that is 9, x will be equal to 9 by 2, that is going to be 4.5. So this is exactly between 4 and 5, that is in between, 9 by 2 which is. So there is no problem. We have verified the Lagrange's mean value theorem here. What will be the second one? See, because you have to find out the point on the parabola. Now you just got the x. How to find y? You have to put this x in the original equation, which is x minus 4 whole square. So 9 by 2 minus 4 whole square. It is going to give you, this is 4.5 minus 4. You can just call it as 9 minus 8 by 2, that is half, 1 by 4. So the xy value which is to be found out in this parabola equation is x and y value. You have 9 by 2 and then we have here the second value which is 1 by 4. So this is the coordinate of that point where the tangent is parallel to the chord which is joining 4, 0 and 5, 1. I hope you got the idea. There is other question also. So this is the solution for this particular question, but the next question is almost like similar to this. And this question we are going to attempt in the next discussion. Till then, thank you so much. Take care of yourself.